Hi, everyone. Thank you for joining us. Looks like we have some folks rolling in still, so we're going to give it a little over another minute or so, and then we will begin. So thank you all for waiting. All right, it is now 1 p.m. Eastern, so we're going to go ahead and get started. So good afternoon, everyone, depending on where you are joining us from today. On behalf of the Environmental Finance Center Network, welcome to the 6th session in our 2022 Water Loss webinar series, Mapping the Water Loss Control and Asset Management Nexus. My name is Avery Davis from the Syracuse University Environmental Finance Center. We'll cover a few housekeeping items and then we will get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording, our evaluation, and other information you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This session has been pre-approved for continuing education credit in the states of Tennessee, Indiana, and California. Attendees from other states are welcome to self-submit this training for credit, but we cannot guarantee it will meet your PDH or CEU requirements. It is your responsibility to check with your licensing agency to see what you need to do to receive credit for your attendance. To receive a certificate for this session, you must attend for the entire duration of the webinar, participate in all polls, and register and attend individually using your real name and unique email address. Group viewing credit will not be acceptable. Certificates will be sent via email within 30 days of the webinar date, and if you have any questions or need assistance, please contact us at smallsystems@syr.edu. Now for a little bit about the Environmental Finance Center Network. We provide training and technical assistance to small public water systems in all U.S. states and territories to help local water systems achieve their goals and stay in compliance with the Safe Drinking Water Act. If your community or utility needs assistance with drinking water system management, please feel free to contact us through our request form, which I will be sharing the link for shortly in the chat. And on that note, I would like to introduce our presenter for today. So we have James Markham, research engineer from the Southwest Environmental Finance Center at the University of New Mexico. So James, I will hand it over to you.
Thanks, Avery. Let me get the appropriate page up and running here. All right, so thanks again for joining our ongoing water loss control webinar series. As Avery said, my name is James Markham. from the Southwest EFC at the University of New Mexico School of Engineering, where we promote self-reliance through innovative training and assistance focused on actionable results. So this is indeed session six. And our topic today is mapping, which we really think of as a nexus or bridge between water loss control and asset management. And it's a tool that's useful for both. And we hope that you'll see that connection today as well after the presentation. Today it's just me and Avery. Don and Heather are off in Guam and Saipan doing much of what we're actually going to be talking about today. They're actually out there collecting data and helping some utilities outside Pan build maps. They'll be back for our final session, which is going to be scheduled for Wednesday, the 25th of May. So put a hold on your calendar. And that last session is going to be focusing specifically on the role that billing and finance staff play in the water auditing process. But today is all about the data, about gathering useful information, making and using maps. And the great thing about digital data collection and mapping these days is that it's become very, very inexpensive, much easier, and it really allows you to make a whole that is greater than the sum of its parts because of the way that you can combine and compare data from a lot of different sources and then do analysis and visualizations. And those visualizations are really important. In the past several presentations, you've seen images like this one, which was our asset management-based water loss control intervention example from Albuquerque, or this one, which was a map of speed and location of repairs at a system in Texas. And the reason we use images like this is because visualizations are a really powerful way to analyze and display data. They allow us to see information in an easily digestible form, and people are really good at spotting visual patterns. We also often find that when we visualize data, things that were thought of as sort of conventional wisdom about a utility are sometimes reinforced, but other times are overturned. And quite often new patterns show up that we hadn't even considered before, or maybe weren't able to discern because of the format the information was in. So robust mapping can tell you a lot more than just where something is and what it is. With the right information included in a mapping database, they can tell you, who is responsible for doing something or who made a repair, when that happened or should happen, why something was done, how something happened, and how much it cost. And those last two are actually really, really important because if you think about, for example, break data, a break from a pipe failure or a pressure surge is very different from a break caused by a construction crew digging into your pipe without doing line location. Of course, they all create lakes, and they all have to be repaired and result in water loss too. But a construction crew break has nothing to do with your pipe's condition. And for that kind of leak also, you actually know exactly when it started. So the loss estimation is easier if you can segregate those kind of leaks out. And same thing goes with costs. You can use historical costs to project expenditures that you're likely to have. So all of this can be done within a variety of different mapping platforms. And we're going to talk a little bit about the data collection process and the mapping because including this kind of information really makes digital maps powerful tools. Digital mapping is really about process, and the overall goal, as I said, is to turn data and information into knowledge to improve decision making, to make a sum or a whole that's greater than the sum of its parts. And so the progression that we're kind of looking for is that everybody in the utility has a variety of information about assets and events, and we want to get that out of people's heads and get it documented formally. So SOPs, other kinds of information. And if we document that in a digital format, as opposed to putting that on paper forms, it suddenly becomes usable in a lot of different ways, because fundamentally that's all ones and zeros, and data can be reformatted to use in a lot of different ways, because digital data we can use for those analysis and visualization that I've been talking about. And we can do those within a GIS program, which are getting easier and easier to use, but you can also do this in a very sort of analog fashion with a big map on a wall with colored push pins that represent different kinds of information. I've seen this done in small utilities, and it can be very effective. Of course, it's a little bit more difficult to do esoteric analysis with that manual process. But no matter which way you do it, the end is that the collective unit that is the utility ends up knowing more, because you've sort of collectivized and combined all that information and really made it available to everyone in the system. I've mentioned that I think of water loss control as kind of a subset of asset management practices, and obviously mapping plays a big role in that. So to get everybody on the same page, I want to give you sort of the quick and dirty 10-minute version of what asset management is. For those of you who've attended asset management trainings in the past, This is going to be a bit of a review for those of you who aren't familiar with asset management, particularly as it applies to water utilities. This is a very short introduction to a very broad topic. So fundamentally, the goal of asset management is essentially knowledge management. Systems benefit by getting knowledge out of people's heads and making it accessible to their teams. Creating SOPs, creating videos, documenting processes. Those kinds of activities result in improved work efficiency, improved emergency response, financial efficiency. They open the door for community engagement, and most water systems engage at least some of these activities through the regular course of business. The point of asset management is to move from sort of an ad hoc reactionary approach to a framework that addresses these issues holistically and systematically. Asset management, as it's defined, is a framework that's essentially designed to help you determine how, when, and where to spend the limited funds you have to achieve the best results. It's a tool for making tough decisions about how your money is going to be spent. In asset management speak, the goal is for utilities to help utilities provide the desired level of service at the lowest life cycle cost. The desired level of service is essentially the service you want to provide your customers with the assets and infrastructure you have. The lowest life cycle cost is the best appropriate cost for your particular system with your particular needs and constraints and infrastructure. So it's a process that's sort of universal, but how it's applied is going to be very case specific. There are 5 major components to asset management that can be thought of as addressing the following sort of series of questions. 1, what levels of service do you want to provide to your customers? 2, what assets do you have to actually do that? 3, which of your assets are actually most critical to providing that service? 4, how are you going to ensure that the assets that you have, particularly the critical ones, do their jobs over their lifespans? And last but not least, do you have enough money to get all of that done? Because none of those other processes are free. In asset management speak, each of those questions is represented by a component title: level of service, current state of the assets, sometimes referred to as inventory, criticality, which is also known as risk management, life cycle costing, and last but not least, long-term funding, although there is a short and medium-term funding aspect to this as well. So I'm going to dig very briefly just a little bit deeper into each of these categories, and then we'll move on to the core of today's talk. So level of service is all about determining what levels of service your customers want, what levels of service you can actually provide, and how you're going to measure performance. And that last part is kind of critical. Utilities, like every other service organization, have competing priorities. You want low costs and high levels of service, and sometimes those are in conflict with each other. So the level of service component is about getting to know what customers are willing to pay for, what they want. It's also about educating the customers as to what can be reasonably provided. But fundamentally, water utilities exist to serve customers, so that question really needs to be asked: what do they want? Typically, it's a finite set of things: professionalism, safety, quality, reliability, affordability. The point is that you can find out what your customers want by asking them. The level of service component really gives you that opportunity to have the conversation so that you can match customer needs and desires to the amount that they're willing to pay for the services that you provide. And when customers have a say in what they want and what they can receive, we find they're often a lot more willing to pay for it. Water utilities work in the background, and unless people are sort of made consciously aware of what it takes to provide the services you do, it's just sort of thought of as something that happens when you turn the tap on. So this is about communicating with customers, understanding what they want, setting realistic expectations, and then using that information to create system goals based on those needs and tracking them to evaluate your performance, because then that in turn sort of becomes a marketing tool as to how good a job you're doing. The next stage is current state of the assets, or the asset inventory, which essentially is all about understanding which assets you have in your inventory, what your infrastructure is, and how that's going to affect your ability to provide the level of service you want. There's a lot of different pieces of information that you want to know, in addition to just what you have and where it is. Condition information is really important. Useful life remaining is really important for understanding intervention and replacement type cycles, understanding what the replacement costs are. There's a lot of different pieces of information that you can collect about different assets. There are some information that is sort of uniform across the board, some that's going to be asset specific or asset class specific. But the point is to understand what you have so that you can understand how your interventions are affecting that. It's not a once and done process. If any of you ever worked retail, you know you do inventory at least on a yearly cycle. Your understanding is really only going to be as good as the most recent looks. So this is something you typically review on a yearly basis once you've got it built. And then of course, as you do different interventions and intervene in with different assets, obviously you're going to be updating condition information and things like that on the fly as well. This sort of naturally leads into that criticality question, you know, which assets are most important, so that you can start to understand how to prioritize your spending and your activities based on risk, not just sort of fixing the next thing that breaks. This is really about evaluating assets, evaluating their condition, understanding their lifespans, and being able to determine sort of the likelihood of failure and, more importantly, the consequence of failure. And then this is also an area where visualization becomes really important, because you can assess all of your assets on a scale and then plot them on a grid like this, and it becomes very apparent, you know, which assets are sort of low risk in terms of probability and consequence, and which ones are sort of at that higher upper right-hand corner that need to be dealt with immediately. So this is, you know, data that you'll collect in an analysis that you can do. This, of course, leads into that life cycle costing piece, which is really the examination of the entire life of assets from the design phase, essentially before you install them, particularly if you're doing a new addition to a plant or facility. Trying to optimize O&M, repair, rehab, and replacement decisions. You know, at a basic level, it's about optimizing O&M, but in sort of a macro level, it's about understanding different ways assets can fail or not live up to the needs that you have, and understanding how you can impact the life cycle by intervening. You know, which things you're going to allow to run to failure, where you need redundancy, where you need to have backups and spare parts, and you know, which things can be rehabilitated, which things should be continued to be repaired, and which assets need to be just ripped out of the ground and replaced. Of course, all of that costs money, so we come to the funding component. To do any of the things we've talked about, you have to have a sustainable funding strategy. So the long-term funding component is really about knowing how much money you're going to need and where it can come from. If you've done analysis on those prior events, you get a better understanding of, you know, which assets are likely to fail in the short term, the midterm, the long term, so that you can start planning for how you're going to pay for that stuff. It's about, you know, getting ahead of that maintenance curve, trying to be more proactive than reactive, but understanding that some reactivity is always going to be a requirement. And I mentioned, you know, we talked largely about long-term funding in the terms of asset management, but you have to think about short and medium term as well, because you have to meet your ongoing operational needs, but also be able to pay for those inevitable capital improvement projects. And I want to point out that this doesn't necessarily mean having all of the cash that you're ever going to need on hand at the moment, but it does mean knowing what you're going to need in that short, mid, and long term, and having a good understanding of where that funding is likely to come from, whether that's loans or grants or rate increases. So that's the 5 components in a nutshell. It's not a linear process, even though I've presented it that way. The idea is that you kind of start wherever you're at and work your way around the system. Asset management is really about incremental change. We talk about it being a journey, not a destination. If you're starting from scratch, we recommend starting with level of service, you know, sort of defining system goals. But, you know, if you've got an inventory pulled together, maybe the next step is criticality for you. And you know, you don't have to do these in a particular order. And as I said at the beginning, most systems are doing some of this, at least on an ad hoc basis, if they're not doing it sort of in a uniform way with a full-blown asset management program. So that's sort of asset management. I think you can probably start to see where maps can sort of fill in here. But obviously, since it's all about making informed decisions, what do we need for that? We need data. So I'm going to sort of shift the conversation a little bit here. We're going to start talking about data collection, and then we're going to move to mapping. And when I talk about data collection, I mean asset data and event data, because you really need both of those. And if you can leverage the 2 of them, again, you can come up with some really interesting information. And I'm going to spend less time talking about specifically what data to collect for a given situation and talk more generally about the process. As I said at the beginning, this is kind of about digital data collection and digital mapping. And we really recommend even small systems head in that direction because it's becoming more affordable. It's really flexible. It's becoming easier and easier to use. And what a digital format does is allows you to build those processes into your day-to-day operations, and it eliminates any sort of manual data transfer steps, which can lead to error being introduced and things being lost. So I'm going to ask my first poll question here. Avery, if you wouldn't mind running that. This is about how you currently collect data on assets and events. We're a little bit limited in terms of our poll choices, so things are kind of jammed here together, but our options are basically, we don't collect that kind of data systematically, paper forms, digital forms, app-based digital data collection, which could be anything from, something tied to your CMMS system, or maybe a tablet-based thing, or maybe you don't know, or you're not a utility. And this is a choose all of the options that you use, because in most cases, or many cases, I see, utilities that use a lot of these processes for different activities. So I'll give you another little bit here to finish answering those questions. Remember to answer this poll if you do want to get CEUs. That's one of the requirements. And then we'll let Avery read off our results for us.
We're going to leave the poll up for about 10 more seconds, so get your answers in if you have not done so already. Okay, we'll close the poll in 3, 2, 1. So it looks like 15% answered they don't systematically collect that kind of data, 35% paper forms, 37% digital forms, 15% app-based digital data collection, and the rest are don't know or not a utility.
Okay, well that is not surprising. That's a very similar sort of curve to what we've seen in other trainings, particularly with smaller utilities. So hopefully some of the talk here today will sort of allow the folks who are sort of in the we don't collect that or we're in the paper form side of things to maybe think about moving to digital data collection. And again, for some super small utilities, it might not be required. I've seen utilities that are small enough where you can essentially do everything on a paper map on your desk. But the bigger the system is, the harder that becomes. And for those of you who are using things like PDFs and work orders, hopefully this conversation will give you maybe some additional options for data collection, and also kind of show how you can leverage existing data that you already have in ways that maybe you aren't doing at the moment. The first question I usually get asked is like, well, how should I collect my information? And there's no single answer to that question. There's a lot of different ways that you can do this. The good thing is, there's a lot of different kinds of equipment available at a lot of different price points. Everything from, a handheld GPS device to smartphone apps that can work with or without a GPS device, to full-blown survey-grade equipment, and all of these can do the job. And each of them has pros and cons. And so what you're going to use is kind of depend on needs and budgets and capabilities. But an important thing to remember is that accuracy and cost tend to be proportional. The higher the accuracy you want, the higher your costs are going to be. Fully integrated survey equipment is going to potentially get you centimeter accuracy, but it's also going to be very, very expensive, potentially in the tens of thousands of dollars. There are many other cheaper and more accessible technologies out there. I mean, if you have survey grade equipment, great, use it, that's awesome. But if you don't, and you're thinking about this, there are much cheaper ways to get into this. A lot of digital data collecting can be done using inexpensive phone and tablet apps, using the smartphones that your staff may already have in their pockets, or that you could easily provide. And on that side of the equation, equipment and software can be had for, a buy-in of less than $1,000. So the first thing you need to think about is how accurate you have to be. Do you have to know down to an inch where something is, or is 3 feet going to be close enough? If I'm looking for a valve, if I can get within a couple of feet, even if it's buried, I can find it with a metal detector. I don't necessarily need pinpoint accuracy on that. With unlimited funds, obviously you could know everything precisely, but we're talking about a real world with limited funds and limited capabilities or possibilities. So you have to ask yourself kind of what you need to know and be practical about it. We do a lot of system asset mapping, both in terms of developing system asset maps from scratch and also helping systems build asset management plans and document the things that they have. And the thing that we primarily use is a tablet-based app with a handheld GNSS receiver and a piece of middle software. And we use different ones depending on the project. The one I'm going to talk about today is Fulcrum. This is not an endorsement. We're not getting paid by these guys. It's not a sales pitch or anything like that, but it's one of many useful types of software like this that does the job really well. And they all tend to work fairly similarly. So we're going to show you a demonstration here in a little bit of how Fulcrum works. And for those of you who don't know, GNSS stands for Global Navigation Satellite System. GPS is actually the US global positioning satellites, but Europe has a set, China has a set, and Russia has a set, although I don't know if we currently have access to that given what's going on in the world right now. So a GNSS receiver basically just has access to more satellites and can give you more precise locations quickly. And you can do all of this with smartphones or just a basic iPad or Android tablet, because most, if not all of them, have GPS chips built into them. The native resolution is typically about 3 meters, but they also work with Wi-Fi and various other things. If you've walked around town using a Google map to find something, you probably recognize it, at least in urban areas or where there's good cell phone coverage. Those are very, very precise. So some of these things you could do literally without a GPS, with a phone that you already have in your pocket, with a piece of software that costs 30 or 40 bucks a month. And there are free options as well for this kind of data collection. This is that Fulcrum's relatively inexpensive. It's something that we use for free because we're at a university. But there are free open source tools available as well. QField is one of them. This is a really powerful open source data collection application that you can just download for free off of Google Play or their website, qfield.org. Open source, for those of you who don't know, basically means that the underlying software isn't proprietary. Anybody can use it, anybody can modify it, and most importantly, it's free to the public. So, QSource has a global group of developers, or QField, excuse me, that is continually improving it. They're building cloud-based features right now. There are some downsides to using open source platforms because the code might not be as updated as often, and there isn't necessarily a dedicated help desk that you can call. But the open source tools that I'm going to talk about today are very, very robust and have huge support networks available to them. And all of these will integrate very, very well with any GIS program. As I mentioned, there are a lot of different kinds of software that can do this. Here's a few more listed on the left-hand side, Collector, which is from Arcgis, Esri, there's Survey 123, Fulcrum, GPS Fields Area Measure, and there's plenty of others. The important thing to recognize before you sort of jump in is that they all work on different platforms and in different ecosystems and have different kind of capabilities. So you have to really think about your existing infrastructure, your capabilities, how it's going to fit with the technologies that you currently use or want to use. So we've got our 4 options in the left-hand corner. You can see all of them work on iOS and Android. I don't even know if anybody still has a Windows 10 phone, but some of them will work on Windows 10, some of them won't. Some of them have online and offline functionality, others don't. ArcGIS, you can do fields and polygons. So example, if you wanted to map out a field, you could do that, whereas some of these other ones are point-based, so you would end up mapping out the corners of the fields. And some of them have web access and some of them don't. I think the best way to show you how these work is to literally just show you how these work. So I've got a quick 7-minute demonstration here that shows you the back end of Fulcrum, the front end of the Fulcrum, and Fulcrum sort of in the field being used. And hopefully, for those of you who haven't looked into this, this will sort of demystify the process a little bit and show you how accessible it really is. And of course, the goal here is not to show you how to build an app from scratch. It's just to show you that sort of in short form how these things work and that they're really not that difficult. So let me pop our video up here and hit play, and I'll see you in about 7.5 minutes.
This is a short video about field data collection. In this case, we're using an iPad running Fulcrum's software and a Bad Elf GNSS receiver. By pairing a GPS or GNSS receiver with your iOS or Android mobile device, you can take advantage of the GPS accuracy of the receiver and the data collection capabilities of your mobile device. Fulcrum has a web interface that you can use to build data collection applications and also to review and edit your data. We'll start by looking at the web interface of a simple hydrant data collection application, and then we'll use that same application to do some field data collection. So what we're looking at here is the designer portion of Fulcrum's web interface for the app that I've built for hydrant data collection. What you see on the left-hand side are the basic kinds of fields that you can use, and on the right-hand side you can see the configured app that I've already created under layout. Each of these different fields are essentially drag and drop. As you'll see here, I'm going to add in a date field, which simply involves me grabbing the date field from the left, dragging it to the location in the application that I want it to be in, and then configuring it with a label and a description. You'll notice there are a variety of different kinds of fields that are available: text, numeric, yes, no, dates, single and multiple choice fields, fields that will do calculations. You can also use the design fields to organize your application. You'll notice I have several sections here, one for field data, one for general data, and so on. By clicking on the pre-configured fields that you've created, you can edit them and verify that the information you're using is correct. So for here, for example, I've got hydrant size with a couple of different size options. I noticed I didn't put in a description for serial number, so I'm going back and filling that in. Under type, I've got 3 options. I'm making this a required field because I want to make sure that data gets collected in the field. You can also preview an application that you've built via the web interface by clicking on the Preview App button. That will show you the basic layout that a mobile user will see in terms of the order that fields are going to be listed in and whether they will be visible or not. For example, you could create an application and hide the office data because that won't be actually used in the field. Obviously, anytime you make changes to your applications, do not forget to save. So let's use this app to go actually collect some data. So I've got my GNSS receiver here, which I've placed on top of the hydrant. And what you're seeing now is a screen capture of the data collection process from the iPad itself. So I'm picking a hydrant type, I'm picking a manufacturer off a pre-configured list. Same goes with the size. In this case, my hydrant does not have a serial number. I'm skipping that. It does have an isolation valve. It's a single color. You notice those red asterisks indicate that the fields are mandatory. Pictures are very, very important. Always take those. In this case, I've actually taken a picture of the GNSS receiver as well. Before I save the record, I check my location. One of the nice things you can do with this is actually modify the place of your record using the base map. There's actually an Android interface for this I mentioned. This is essentially the same data collection application, but you'll see that the layout and the interface is slightly different because of the different operating systems. That being said, the list of information is exactly the same. It's just laid out a little bit differently. So once you sync your data with the cloud from your mobile device, all of that information that you collected will be available on the web interface, and anything that's been added to the web interface since the last time you synced will now be available on your mobile device. So we're going to view some of the records that we've collected. These little pink dots represent hydrants that we've collected in and around the UNM campus area. I have a couple of options in terms of how to look at them. I can look at just the data. I can look at a combination of the data and the map. I can also filter each of these various conditions. So for example, if I just want to see my Mueller hydrants, I can click on that and it will reduce the list of those. And if I go back to my map and look at them, the only thing that will be shown are the Mueller hydrants. You'll notice I have a somewhat busy base map back here. I'm going to change that for ease of use to a simple street map, kind of like a Google map, which clears away some of the clutter and makes the points a little bit more visible. So you can see a few of them scattered around. I'm looking at records that are in this field. There are about 31 total. It's showing me the records below that it can see in the map. So if I zoom out on my map, you'll see the records below get populated to reference everything that's currently in the visual frame of the map. I can do a quick view of the data related to any record, which will essentially give me a short form layout with all of the information. I can also click on the picture and it will bring me to a more detailed picture relating to the image itself, which not only shows me the picture, but where I took it and some metadata about the image. Now, obviously, once the information's up there, I'll probably want to download that. I've got a lot of options: CSV, Excel, Esri shapefiles. I can download either the filtered or the unfiltered data from here. I can also download this information from the main app page where we started out by simply going to the exporter. The advantage I have here is that I can download multiple files from a lot of different apps that I have created.
All right, so brief demo kind of gives you a flavor of what can be done. And again, the goal here is not to teach you how to build an app from scratch, but to kind of show you the sort of ease of configuration. And because of their flexibility, it's really easy to develop lots of different kinds of apps to meet your needs. You might have one for break detection or break data collection, another for field asset condition information, a third to assist your staff out in the field doing maintenance. And this is where this kind of app can really shine, in both, the data collection side of things, but also the information transmission side of things. Because once the data is captured, it's available for anybody in your utility to use, both in the office and in the field. And you can literally, backload these apps with information sitting in your office so that it's available for folks out in the field. And I'll give you an example of the kind of thing that you might use this for. We worked with a system not too long ago that had valves that closed in two different directions. They started a valve exercising program that quickly turned into a valve replacement program because they sent out inexperienced staff who were unaware of the differences, and they proceeded to break several valves. With that kind of information in an app like Fulcrum or one of the other apps that we've talked about, staff on site would literally be able to pull up the information about the valve that they're sitting in front of, look at the relevant information, prevent that sort of costly mistake, and then also update the fact that they've done the maintenance. And as I said, these kinds of activities, with some planning, can really be built into daily operations and kind of happen seamlessly in the background and really give you a much better picture of what's going on in your system. So that's sort of a brief review of the data collection side of things. Let's talk about mapping, because obviously once you've collected that data, it's useful to have in spreadsheets, but visualization is where it becomes really powerful. And here again, I want to point out that there are both commercial and open source options available, open source being the non-proprietary free software that anybody can use. The gold standard in digital mapping is Esri's ArcGIS. You've probably heard of it. You may be already using it. It's been around forever. There's an integrated suite of tools for data collection, mapping. There are a lot that are utility specific, and Esri has some programs that are designed specifically to help utilities get onto their platforms. The downside with Esri is that it's not free. It can be quite pricey, but prices are coming down, and there are some licensing options available for small utilities that I think are around $1,500 a year, which pretty much give you access to the whole shebang and and essentially allow you to access a very, very powerful tool somewhat inexpensively. That being said, maybe you don't have the budget, or maybe you're thinking about getting into the world of GIS, but don't want to make that kind of commitment. QGIS is a really powerful open source project, and this is the GIS backend for the QField program that I talked about in the data collection side of things. These two integrate really well. That being said, Fulcrum and other data collection apps like that also pretty much integrate across the board with all of these different mapping softwares. You can really sort of plug and play and decide what you're going to use. Like ArcGIS, QGIS has a database backend that lets you do really powerful analysis and visualizations, and you know, push the data from your various sources together. It's free. It's maintained by a global group of developers and users. Of course, you know, they don't necessarily have a help desk dedicated to answering your questions the way ArcGIS would have. But that being said, it's a really powerful tool. It's used by national governments and state governments around the world. And this is something you could literally learn to use by watching videos on QGIS's website and going to YouTube. Another option you have is Google My Maps. It's a free option as well. And what you're looking at actually is data that was collected by Dawn and Heather yesterday on lift stations in Saipan. Just to kind of give you an idea of how quickly this stuff can be made live if it's available. Google My Maps is great. You can create maps, you can share them with people. The downside of using an application like this is that it's really good for the what and where, and you know, conveying some of that information out in the field, so somebody could go to the lift station and click on it and get some information about it. The downside is that you don't have sort of the back-end database analysis capabilities that a GIS program has. That being said, it's, you know, even something like Google My Maps is really, really useful because you know, you're going to be out there looking at it on a tablet or a phone that has a GPS in it, and it can provide a lot of that information flow back and forth. Of course, the data collection apps themselves, like Fulcrum and many others, can be used as mapping platforms. I've seen small utilities just get Fulcrum, plot all of their information in there, color code it, and use that to sort of know where things are, because they can access things in the field and they build the apps that they need and share data among them. So, you know, like in the valve exercising example I gave you before, you could set that up with the information, the instructions, and a couple of different statuses, so that when the staff went out there and did their job, they could mark it as exercise, and then, you know, that would be tracked in the database. Staff back at the office would be able to track the project as it was occurring effectively in real time. Again, you know, the goal here is not to teach you how to build a GIS map, but to sort of demystify the process a little bit. So what I'm going to do now is show you another video. This is one of my associates, Luke, building an ArcGIS map and a Google map using the data you saw me collect in the earlier video in real time. And he'll do both of these in less than 10 minutes. So once again, sit back, grab some popcorn, and I'll see you in about 10 minutes.
This is a quick video on mapping field collected data. In a previous video, we covered how to design and use data collection apps to gather data. In this video, we will map the data we have collected. First, we will map the data in Esri's Arcmap program using the shapefile we downloaded. We start with the Arcmap program opened to a new blank map. Using the Add Data button in the upper left, we can bring our shapefile into the map by clicking Add Data and browsing to the file location of the shapefile. Select the shapefile, click Add, and we can see the points we mapped for hydrants drawn in the map view. We can see the data layer we just added listed in the table of contents on the left. By right-clicking this layer and selecting Open Attribute Table, we can see the attribute data that we collected in association with each point. Now let's give these hydrants some context by adding a base map. We can do this by clicking the Add Data button and this time selecting Add Base Map. There are a number of different base maps to choose from. Note that the use of these base maps requires an active internet connection, as the base maps themselves are housed on Esri servers. We will use a topographic base map for now, by selecting topographic and clicking Add. Now that we have a base map, these hydrant locations are starting to look good. Next, we will cover a few simple ways you can symbolize your data. Right-click the hydrant's data layer in the table of contents and select Properties. From the Layer Properties window, navigate to the Symbology tab. On the left, in the column under Show, select Categories. This will allow you to divide the data into categories and symbolize each category differently as opposed to using the same symbol for all hydrants. Once Categories has been selected, click the drop-down menu under Value field. Here, we are selecting the field from the Layers attribute table that we will use to symbolize the data into categories. We will select the Manufacturer field to symbolize the hydrants by their manufacturer. With the field selected, we then click the Add All Values button on the bottom. This adds each unique value from the manufacturer field in the Layers attribute table. We can then assign new symbols to these values by double-clicking the symbol shown next to each value in the center. This opens the Symbol Selector window where a new symbol may be assigned. We will give each manufacturer a new color and increase their sizes a little so we can see them better. Using the Identify tool, we can see that the symbols have been applied correctly. If you would like to use custom or predefined symbology, you can import symbology from a .lyr file. We will do this using a .lyr file we have already created for this purpose. To do so, right-click the hydrants layer in the table of contents and select Layer Properties. Back on the Symbology tab, click Import in the upper right. On the Import Symbology window, leave the first radio button selected that says Import Symbology Definition from another layer in the map or from a layer file. Click the yellow folder icon to browse to the location of the .lyr file that you would like to use. In this case, we will select our water hydrants.lyr file and click Add, and then click OK. The symbol from the .lyr file is shown in the center, and by clicking Apply, all hydrants in the layer will be drawn with our custom symbol. Next, we will cover the basic process for mapping our data in Google My Maps. Google Maps and Google My Maps are different sites. On the My Maps homepage, select Create a New Map in the upper left. This opens up a new map with a base map and one empty data layer. You can switch between a variety of different base maps using the Base Map drop-down menu on the left. To add data into the empty data layer, click the blue Import button under the layer's name in the table of contents. The Import window tells you which file types can be used with My Maps: CSV, XLSX, KML, or GPX. You can drag and drop the appropriate files here to add them to the map, or click the blue Select a File button to browse to the data. We will browse to the KML file we downloaded from Fulcrum. After selecting the file, the data is added into our map. Using your mouse scroll wheel or the plus or minus buttons in the bottom right will allow you to zoom the map in and out. In the table of contents on the left, we can see all the points in this layer. The data we collected for these points can be accessed by clicking the menu button to the right of the layer name, represented by 3 vertical dots, and selecting Open Data Table. The Individual Styles button under the layer name gives us options for how to symbolize the data. The Style Data by Column option allows us to select an individual field from the data table and symbolize the data based on those values, like we did with the manufacturer field in Arcmap. For now, we will select Uniform Style, which will allow us to apply the same symbol to all points in the layer. In the table of contents, where each individual point used to be listed, it now says All Items. Using the Paint Bucket button to the right of All Items, we can set symbology for the layer. Here, we can change the point's color or select from a few popular icons. The More Icons button on the bottom shows you the full list of icons native to My Maps. To use your own custom symbol, click the Custom Icon button on the bottom left. This opens the File Import window. Just like when adding data to a layer, you may drag and drop the appropriate file here or browse to it by clicking the blue Select a File button. The file types that Google My Maps will accept for symbology are image files, such as JPEGs or PNGs. We will browse to the image file we want to use for our point symbol, in this case, our hydrant PNG image. After the image file has been selected, you can see our new custom icon in the list of available icons. With our new symbol selected, clicking OK applies the symbol to all points in the layer. When you have completed building your map, you can share your finished product using the Share button on the table of contents. After clicking Share, you will be asked to provide a title and description for your map. Next, in the Sharing Settings window, you will see at the top a link to your map has been generated. This link can be shared via Gmail, Facebook, or Twitter using the buttons below your link, or you can copy and paste the link directly. You can configure the privacy settings for your map in the Who Has Access section. You may also invite individuals to view your map by name or email address in the Invite People section. Clicking Done will apply any changes you have made and send invitations to view your map to the users you have specified, if any.
All right, again, the goal is not here to show you how to do a map, but to show you in real time how quickly a map can be produced with a program like Arcgis or Google. My maps from data that you've collected. There is obviously a learning curve, but it's probably not as steep as you think. This is also something that we can help you with, and many other service providers like us are able to help you with. Want to point out a couple things. Sometimes, you're going to be leveraging data to make maps, as we've been showing here, but you probably have a lot of existing maps with a lot of really useful information in them as well, and those can be leveraged, to develop data. And it really doesn't matter which direction you go in. You'll probably be going through both over time if you go down this road. You turn data into knowledge, and that's the really important thing, is that you're sort of gathering all of this information into a single platform where you can really bounce everything off. So I'm going to ask our second poll question here. Remember to answer that if you're looking for the CEUs, and this is just to sort of enlighten us to what kind of maps you currently develop and use in-house in your utility. None, as-built, maybe paper maps beyond as-built, digital maps, and that is a wide range. Again, you've seen the variety of options that I've talked to you about. Some work order systems have some rudimentary mapping capabilities. You might have a CMMS system that has some mapping stuff in it as well, or then again, don't know and not a system. So we'll let Avery run this poll, and we'll look at the answers, and then we'll sort of end by showing you sort of an example, which you've actually already seen, but I'm going to explain it in greater detail to show sort of the links between the asset management and the water loss side of things, and the kinds of things you can do with really minimal amounts of information if you have them.
Okay, we're going to leave the poll up for about 10 more seconds. And it will close in 3, 2, 1. So it looks like 4% answered none, 47% as built and blueprints, 38% paper maps, 49% digital maps, and the rest are don't know or not a system.
Well, that is really encouraging because half of you guys are already using some form of digital mapping already, and that is great. And for those of you who are going sort of above and beyond, just blueprints, great as well. And again, I imagine many of the systems out there are using a combination of these things. For those of you who are using none, unless you're a very, very small system, at least make a map of your system if for no other reason than legacy purposes. I have a system that I'm working with up in northern New Mexico where they literally don't know where anything is because the operator who'd worked there for 60 years passed away, and the blueprints that they have are a good 30 to 40 years out of date. If for no other reason than legacy purposes, developing some basic maps, even if they're not digital, is a good way to go. So as I said, I wanted to give you a brief example of sort of one of the projects that we worked on. The image will be familiar to you. This is sort of combination asset management development plan for a system that was dealing with high levels of water loss. And they really only had some very rudimentary information. They had physical map books, and each of the operators had one. They'd been annotated with a variety of notes. Some of them were inconsistent, but they had a lot of information in these in this format, and some of it they had in a digital format in terms of CAD files, but those were incomplete. The other thing that they had was rudimentary work order data. They had a work order system but it didn't really have any real logging capabilities. So they did a workaround, and they built a spreadsheet where they tracked calls that came in. And with these two pieces of information, we're actually able to build some pretty powerful information. And I would like to point out that even though this form, this call log is in digital format, they actually mostly used it in a printed form. They would print it out at the end of the week for their weekly meetings to see what had been done and what hadn't been done. But using just those two pieces of information, we were able to build a GIS map of their system. We took all of the annotated information from their maps. We scanned those paper maps, and you can actually see on the left-hand side of the page here an image of the map overlaid. We basically scanned it, made them semi-transparent, overlaid them onto a base map, and drew in the entire network with all of that attribute information that we had. We also did a bunch of field data collection, so there are many other layers to this. We have one for valves, one for hydrants, and et cetera, and one for meters, but I kept it simple just so that you could sort of see this. This is something we did in a relatively short period of time, just using paper map books. And by doing that, we already had essentially developed an inventory database, and we had a lot of critical information in there, like when things had been put in. Even if we didn't know the exact year, we knew approximate time and what materials there were. So we start building out our asset management database, and we start to know more about the pipe network that we're having all of these leaks on. We also took the work order information for the call log information and plotted it. This is the same image you saw during the real loss, where we've got location of breaks within the last 18 months, color coded by how fast we repaired them. Green's 1 day, yellow 2 days, and red more than 2 days. So I can start to supplement my condition information because I know where breaks are happening. I see there's some areas where I've got repeated breaks. So I'm supplementing the inventory that I just created with condition information. Because I've mapped how long things are taken, I've also got level of service information. So maybe I've got information now where I can set myself some goals and say, okay, 48 hours is a reasonable amount of time for my utility to repair leaks, and that's what we're going to shoot for, and that's what we're going to let our customers know. But remember, I said that sometimes we see patterns that corroborate what we know, and other times we see patterns that don't. And this was an instance of the latter. This upper corner here was thought of as a really problematic area, and it was sort of conventional wisdom was there's breaks here all the time. This area is a big money sink, and the data that we had didn't really show that. We showed 3 or 4 breaks. What was that? 4 or 5 breaks, I guess, in that area. And so we had this conflict between what data was showing and what we thought we know. What do we do? Investigate, obviously. And this was kind of an unusual situation because these particular streets hadn't been repaved in 20 years. So we were able to supplement this basic information we had here with pavement cut information. So we looked around, thought, what can we use as a proxy for breaks? Holes in the pavement. Repairs in the pavement. And because we had the operators there and we talked to residents, we were able to discern, which ones were water main and service line repairs and which ones related to sewers and others. So we were able to segregate. And granted, this information probably wasn't perfect, but it was a lot more information than we had before. And this was collected using Fulcrum. And when we added that information, suddenly we've got a much clearer picture of the break frequency in this area. So we've got 20 years of breaks now. And we can see even within this area, although this is sort of known as a really problematic neighborhood, recently the breaks are very isolated, and even over history, the problem areas are up here and down here in that circle. But again, I also mentioned patterns showing up that you didn't really see before because you weren't looking at that information. And this street right here was something that wasn't really on anybody's radar, but there had been 27 breaks in the last 18 to 20 years in this location. So now we've got even more supplemented asset inventory information, condition information. We've still got our level of service information, and now we've got some criticality information as well, because we're knowing, where things have broken is where they're probably more likely to break. We've got some ability to know where our problems are and start thinking about, well, what's the consequences of these? We also are able to start doing life cycle costing here because we know what repairs cost us. We know how many of them we've had to do. We can start to sort of project forward and determine, well, am I getting the best bang for my buck? I've got data that shows me that the pipes are in worse condition, that are eating up repair funds. I can start thinking about what is are likely to cost me in the future and whether other interventions might be better. And we don't just look at this at the micro level, we looked at this at the macro level as well. This is the same city zoomed out from 10,000 feet. It's a single source city, which is down south, bottom of the page, about 20 miles outside of town. We noticed they've got a significant problem with breaks on their actual main transmission line. And if this transmission line is down, they have no backup source of water. There is no interconnection with anybody else. They do not have any wells. All they've got is the 3 tanks. And at this point, they started thinking about, well, how has my city changed? We now have 5 prisons. We have a military base. The town has grown. Do we have the capacity that we really need? Do we need to change how we're doing our operations and maintenance? Do we want to focus on repairing the pipe in that problematic neighborhood, or do we want to maybe take that money and focus on the transmission line, which is going to provide a better service for everybody else? And of course, last but not least, we've got the money aspect. Because we had some cost information from this utility and backup cost information from a variety of other sources, RS means, state websites, we were able to throw in per mile replacement costs and other costs into Arcgis and take that information and supplement it with dollar amounts. What we're looking at here is sewer line of a certain age. They were originally planning on replacing their sewer line by age, and we were able to quickly show them that the budget for that was going to be close to $10 million. That's that number up here, the sum, which was about $8 million more than they had. And so we started looking at other ways to maybe focus on critical pieces of pipe or problematic pieces of pipe and do that job in a piecemeal fashion. So quick and dirty explanation, but fundamentally by applying asset management techniques, they're able to sort of use their money more wisely and have a significant impact in their water loss situation. The next step from this was to start to include water loss event information going forward, so that they would be able to calculate estimates for losses from different size breaks based on the pipe size and the pressure. And of course, collecting all of that event data would put them in the position to do the component analysis activities that we talked about during the real loss. And you can take the calculations and pieces from component analysis tool and actually build them into a GIS, so that is happening in the background. So that's just one example. I've got a couple more. I realize we're out of time here. I want to just make a few comments and then we'll open it up to questions. Mapping is, as I said, about process. Don't just jump in willy-nilly, make a plan, decide what information you want to collect. You don't have to collect everything, collect useful information and figure out, your time frame, what tools you need. Once you've got that figured out, put together forms, go out and collect data, combine sources. There's a lot of information in a lot of different places that you can sort of supplement, and you don't have to do this all in a weekend. This can be done over time. It's all, again, about incremental change. Proof your data, recognize that data from different sources is sometimes going to conflict. You'll have to make sense of those, but as you develop more and more data and as you do more field data collection, things will come out in the wash and you'll end up with a clearer picture. And then ultimately, if you're going to go down this road, make maps and use them and improve them, because just like the inventory, map is a snapshot. And if you don't keep them updated, they're not going to be all that useful for you. The nice thing about a digital mapping system is, as information is filling in, in real time, you can update that snapshot essentially on a daily basis if that's what you really want to do. The point here is, harnessing collective knowledge to make better, more informed decisions. There's a lot of information about some of the tools that we've talked about and other aspects of water loss control and asset management on our website, which I highly encourage you to go see, swefc.unm.edu. We've got a water loss switchboard that has water loss specific tools. We've got an asset management switchboard that can really sort of walk you through getting the asset management process started. And we've even got a state revolving fund switchboard, which can help you with the funding side of things. And we just released a rates tool that will enable you to sort of look at your rates and put in various information about your utility and determine affordability and things like that. Last but not least, recognize you don't have to do this alone. We are here to help. As we've said many times, there's free technical assistance that goes along with this series. If you're a system that serves 10,000 people or less, please reach out to us. We're happy to talk about this. We're all kind of data geeks, although we like to get our hands dirty as well. And with that, I'll open the floor to questions if we have any. And if not, I thank you for attending. Here is our contact information. And I'll probably stay on for a little while because I have two other examples that I can show if anybody's interested in seeing them. So do we have any questions?
We don't have any questions at this time, but if any of our audience members, if any questions come up, please, now is the time to submit those, and you do that in the questions box in your control panel.
I do see one question. When did the EFC form? I'm not sure when the Syracuse EFC formed, but the Southwest Environmental Finance Center is actually celebrating its 30th year of existence this year. And our director, I believe Heather's been here for 26 of those, leading the charge. So we've been around, and I believe there's like just a big funding proposal that went out for developing more EFCs. So hopefully in the coming years, there will be more than just the basic 10 of us out here providing assistance and training to utilities like yours.
While we wait for questions, I know some folks have to jump off, so I'm just going to do our cover a few closing items. So following this webinar, all of today's attendees will receive a follow-up email with the survey and a link to today's recording. We also post all of our webinar recordings to the EFCN YouTube channel, and I've shared a link in the chat to our water loss series playlist on that channel. So if you'd like to have access to all of our webinar recordings, you can go ahead and subscribe there. James mentioned at the beginning, but we will also be opening registration soon for one final session of this series on Wednesday, May 25th at the same time from 1 to 2 p.m. Eastern. And it looks like we just had a question come in.
Okay, let's see. I currently uploaded to Google Earth, but it's not interactive or out in the field. So as Luke mentioned, Google Earth and Google Maps and Google My Maps are slightly different platforms and have slightly different capabilities. Again, you know, the Google tools are not going to be nearly as interactive as something like Fulcrum or one of the other sort of data collection apps that we talked about. That being said, you should be able to download that information or take the information that you already have and perhaps transfer it into, you know, Google My Maps, which you could share. And then there is some configuration capability there where you can determine sort of which fields are going to be displayed if somebody's, for example, out in the field and, you know, taps on a specific asset. Christine, I encourage you to please reach out to us. You know, my associate Luke is really good at this kind of stuff and would be happy to help sort of walk through the specifics. Typically, if you got the information into Google Earth, it can be put into Google My Maps as well, and probably be made a little bit more useful. And that's the nice thing about these things. You know, the data formats are not quite interchangeable, but they can be reformatted fairly easily to work with various programs. Not a question. I'm going to stick around for the other two examples. Thank you, Francisco. It gives me a reason to keep talking. The official part of the presentation is over now. So, you know, if you do have to go, you know, thanks for sticking around for the extra 10 minutes. I apologize for going over, but I will walk through these other two examples, just you know, for interest's sake, and maybe they'll focus on or result in a couple more questions. If you're worried about CEUs, it is okay to sign off now. You will get credit. The other two examples that I have, one is actually, we came at it starting from a water loss control program. This is one of the islands out in the Pacific where they have 60% water loss. And they were really looking to mitigate and reduce water loss and plan for system repair and replacement. And part of the problem that they had was that they had an incomplete understanding of their system. A lot of it was sort of jerry-rigged and put together in strange ways. These guys actually had survey grade equipment that they used. They actually spent a lot of money on survey grade equipment so that they could capture precise locations, which actually turned out to be kind of an interesting process because we were able to use the precision of the break information to show errors in the mapping that they had, because they had used maps based on as-built and CAD drawings, and they were imperfect and incomplete. In this case, what you're looking at is a section of their pipe network. You can see things kind of don't line up correctly, and there's the red dots or breaks, which some of which are near pipe, some of which are nowhere near pipe. So what we did is, based on talking to them and understanding sort of the inaccuracy of the underlying maps, we used some mapping tools within ArcGIS to snap breaks to the nearest pipe within a certain range. And I can't remember off the top of my head, but I think we used like up 20 feet roughly as a window. So if a break was 20 feet from a pipe, we would snap the break to that pipe. And to use that to see what was left, because another problem that they had is they knew it was incomplete, but obviously they didn't know how incomplete it was. So we did that pipe snapping, and we ended up with a series of maps that look like this, where you can see most of the breaks are on lines, but some are just sitting out and floating out in the middle of nowhere. And so what we did is we used these breaks that had been associated with lines to do that sort of a similar process to what I showed you in the Texas example, where we sort of associated numbers of breaks with pieces of pipe. And we also had frequency information here because all of these breaks were time-stamped. But then we used these breaks that were nowhere near pipe as a proxy to kind of estimate how much pipe was likely to be missing, because at a bare minimum, you know, these breaks, you know, they're linear, they're probably connected to this pipe. So we know that somewhere in here, there's probably a piece of pipe that's at least this long that's missing. And we were able to kind of run a query across the entire network to give them an idea of how complex, you know, that mapping piece was going to be. This is also a situation where, you know, the tools that they had were useful for this instance, but because they hadn't configured them very well, they weren't all that useful. They had precision information on where the breaks had happened, but they weren't really collecting any of the other information, such as when they had occurred, when they'd been reported. So one of the things we helped them with was building that back end data collection piece so that we knew more than just where things were. That being said, even just knowing where these things were was really useful. We were able to map every break in the entire system, and because of that, we were able to show that here, like just about every other system we've ever worked with, the breaks are not evenly distributed. So we did, essentially a hotspot map to show them what the most problematic areas were in a very problematic system, so that they could essentially, fix start fixing their network, their distribution network, with an eye to reducing this sort of catastrophic water loss that they had. Because the other issue, these red areas not only have the most breaks, but they have repeat breaks. It's in the situation here is that there's undersized pipe and things aren't really built in an appropriate way, and so they're essentially in a chasing breaks mode. They fix a break and it just causes a break further down the line. So doing this kind of analysis gave them functional focus areas for both looking for leaks, but also making those infrastructure changes. And then again, because of cost information and various other things, we were able to sort of leverage all of this to figure out, like, well, okay, if we want to hit these hotspots and replace them with 6-inch PVC pipe, what's the ballpark that's likely going to cost? How quickly can we do it, et cetera, et cetera, et cetera. So that's like a small system. This last project is somewhat similar to the Texas project. These guys were focusing primarily on capital improvement. They had an old system. Some of the pipe in the ground was over 100 years, or close to 100 years old. Cast iron through brand new PVC, and they knew they were going to have to make a huge investment, and they wanted to do this in a strategic way. And despite the fact that this was a rather large city, we work for big utilities as well as small ones, like on this project. All they had in terms of maps was paper maps. So they were basically in the same situation that a lot of very small systems we work with are. It's like, we've got blueprints and that's it. What can we do with that? But even with that, these blueprints had a lot of information on them. You can see the original on the left-hand side. It's old, it's weathered, but there's a ton of information, pipe size, lot information, etc. We scanned those. We pulled out pieces of the network for a pilot area, because they wanted to kind of see how this would look and how this would work. Because again, we're happy to help, but we're more in the sort of role of teach a person to fish rather than do all the fishing for you, because this kind of analysis can be done in-house. So you can sort of see the intermediate map here, where we've cleaned up, done some Photoshop to clean up the background smudging. Highlighted different pieces of pipe and different sizes of pipe in different colors, and then we did the exact same process. We scanned these on a big scanner, 36-inch wide scanner, made giant PDFs, pulled them into Arcgis, made them semi-transparent, laid them out, and created a base map. And these guys were great. They actually had 30 years plus years worth of break data in their work order system, and so we were able to pinpoint with pretty good accuracy, based on the addresses, where these breaks were happening. And this also was, like the Texas example, looked at as a super problematic area as a whole, which is why this was picked. But as you can see, the real problems are very isolated. Most of this area hasn't had a break in the last 30 years, and even the pipes that have, they've had one or two, so they're probably nowhere near end of life. Zooming in, you can see even within this really problematic area, there are areas that are bad and areas that are worse, the worst one being up here. You can also see that they've got a functional area for investigation. There is a lot of problem in this blue circle, high number of breaks. We don't know why, obviously, what's going on here. But we've got a couple of things. We've got an area for investigation. We've got some frequency information. If we want to do increased leak detection, it's maybe not and have a limited amount of funds. Maybe this is the area we focus on rather than the whole area. Or if we're going to do some repeated collection. So, this kind of information obviously doesn't tell me why things are breaking, but it gives me an area to investigate, and I can start digging into that. And again, even within this area, there's some localized issues. There's this bit here, there's this problematic piece over here. So, I could address a lot of the loss in this area and a lot of the repair expense by just going after a few critical blocks. And that might be a more functional area. I talked about sort of the element of time in these kinds of breaks. This is on the next slide, are two of the most break prone areas. And since we had that date information, we didn't have the exact start and stop area, but we could look at break frequency. And what we're looking at here on this block is, starting out in the early 2000s with a break about every 2 years, and by 2016 they're happening at about 3 breaks per year. So we've got frequency information, again, more targeting information, we've got more condition information. We can use all of this to sort of build out our asset inventory, do that criticality, do that costing piece. So what area do we target to reduce loss the most, get rid of service interruptions? These areas where the breaks are increasing. This is the most problematic area here, but even here, most of the problems are in that back end corner. So maybe you can't reduce this whole loop, but if you could replace this section, that's where most of the current problems are. So again, doesn't necessarily tell you why things are breaking, but it provides areas of focus. And by addressing these, you potentially change the way you're spending money, the way you're doing interventions, operations, maintenance, repairs, replacements, and at the same time, you're tackling water loss at the same time, as you're doing this. So that's the last of my examples. If those have spurred any questions, I'm happy to answer them. If you've got information that you would, break information that you'd like to do, we can do these kinds of analyses relatively quickly. We've done them for many systems in New Mexico and around the country, to sort of take the information you have and maybe give it back to you in a more useful format. So, please reach out if you're interested in this, or you're interested in learning more about the kinds of tools that are available to you. Because again, as I said, we kind of geek out on this stuff and love to talk about it and love to fix things. So.
Great, thank you for sharing those extra examples. It looks like lots of people found this helpful, so we appreciate seeing those. And I don't see any more questions coming in, so I think we're good to go ahead and wrap it up. So I'd like to extend a big thanks to James for sharing his expertise with us today. I know I learned a lot, and I don't do this stuff for a living, so I hope lots of you found it helpful.
We're gonna make you a trainer yet, Avery.
We'll see. And yeah, James, any final words before we close out?
Nope. My contact information is there. Again, thanks for listening to me natter on for an extra 20 minutes over the allotted time. I get kind of enthusiastic about this stuff. Our information is there. Again, we're back on the 25th. We should be sending out information on that in the next week and a half or so. Again, that is intended primarily for folks who are in the billing and finance side of your utilities. They are really critical to developing data for water auditing. So if you've got billing folks in a system and you're interested in doing auditing, it's going to be a shorter session, probably only about 35 to 40 minutes, because we don't have to cover sort of the breadth of topics that we normally do in these, but I think it would be useful for those members of your water loss control team who are interested in the finance side of things, or who are involved in the finance side of things, to come so that they can have a better understanding of the kinds of information that they need to provide, and have a better understanding of how to answer the questions that you're likely to be asking them in the audit process. So with that, thanks again for joining. We'll see you next time, and enjoy the rest of your day.